Hi, I'm Chris Owens, CEO of OXA, based in Seattle, Washington. Our team across NASA, academia, and industry works in precision materials analysis in extreme environments. I'd like to share the potential for remote control general purpose microanalysis at Artemis Space Camp, the proverbial quote-unquote tricorder from Star Trek. When a Trek away team arrives at the surface, the first thing they do is use tricorders to scan for resources, identify threats, and start returning science. On-demand, in-situ precision chemical sensing is a massive enabler because you don't need to wait to get home to get at the science. Space spans huge length scales, orders of magnitude above a meter, all the way down to the sub-nanometer. Some examples of the science of the small are mineralogy and morphology of sub-millimeter regolith, like this lunar dust speck on the left, identification of phyllosilicate clays and traces of cryogenic alteration to potentially lead us to aquifers. Studying exogenous contributions like this 1/4 millimeter size micrometeorite impact crater and its crustal residues. Study of pyroclastic deposits and lunar volcanism for redistribution of materials on the surface. And finally, ground truth understanding of space weathering, which can be tied to remote sensing. On the engineering side, microanalysis gives efficient ID of desirable elements in raw materials, like checking feedstock and output quality in ISRU and ISM scenarios to make sure you actually made what you intended to make. Next slide, please. So precision trace analysis down to the nanoscale enables general science of stuff on the lunar surface. Two flight-proven tools, in our opinion, provide the most sensitive materials measurements available. The first is scanning electron microscopy with X-ray spectroscopy. This is a material science workhorse. And the second is precision mass spec. This is a chemistry workhorse. Our MOCHI payload is a compact human spaceflight rated electron microscope, currently part of the backbone of services on ISS as a national lab facility. And Cosima on the right here is a robotic mass spec that was flown on the Rosetta mission to study comet dust. Together, SEM and mass spec provide a comprehensive materials picture, which is trace element ID and trace chemical analysis and micro and nanoscale structure. We've been honing remote ops on ISS to minimize crew time while maximizing science and engineering return, including analyzing Martian meteorite ALH 84001 on orbit. We've also practiced several EVAs with astronauts and civilian scientists at the Aquarius Reef Base in Florida to analyze unknown samples harvested from the environment outside the underwater base. What a static base really enables for in-situ science is good sample prep to get the most out of these tools. So in science and engineering, you get what you measure. And the more you measure, the more you get. So let's bring to Artemis Space Camp multi-purpose sensitive tools that can measure down to the tiniest details, bridging the micro to the macro for a complete picture. We're currently preparing a version of MOCHI for the lunar surface. And to learn more, feel free to search YouTube for ESA AstroChat's video, Materials Science in Space. Thanks for listening.